Proposition 6. In this, we look at an isosceles triangle in a way where we first have the base angles given, which are equal to each other, and then we say the sides on those base angles are equal. So it says, if in a triangle two angles be equal to one another, those are the base angles, the sides which subtend the equal angles will also be equal to one another. This is essentially a corollary to proposition 5, this one, where we had the equal sides AB, AC, and the angle ABC and ACB was equal. Here what we are saying is we have a triangle ABC. The angle ABC is equal to angle ACB. And if that is the same, they say that AB is equal to AC. This actually does not require any construction. It's just reasoning. So the reasoning is fairly easy. And I think this is the first time Euclid is using proof by contradiction. So he contradicts what he's saying. We'll not measure anything. We'll just draw a triangle and we'll reason it out. Assuming these two sides are going to be same. So he says there's a triangle A, B, C. He says for if AB is unequal to AC. So the contradiction he takes is that AB is unequal to AC. This is the contradiction he's taken. And you remember this angle and this angle are same, right? Angle ABC is equal to angle ACB. Okay. So he says let AB be greater. So assuming AB is greater than AC. So this is the assumption. Then he says take AC and mark it on AB. So suppose, and that we know from one of the propositions, that we can take a smaller line and take that length and build it on a longer line. So that is possible from proposition number 3. The proposition number 3 is used both in proposition number 5 as well as in proposition number 6. So suppose this is the point we get where we mark AC, the smaller, that assumption, on AB. So let's just draw the line. So nothing is measured here. This is just for illustration, because this is just reasoning and not actually construction. So we've joined DC. Then since DB is equal to AC, DB is equal to AC. Why? Because we assumed this was smaller. We took this. So we have, in this case, DB is equal to AC, and BC is common. We know BC is common. Therefore, the two sides DB, BC and AC, BC will have an angle contained between them. So the angle DBC will equal to angle ACB, right? And therefore DC is equal to the base AB, right? So this triangle, which has this as the base, this triangle, this has the base, will be same. So what they are arguing is this will now be equal to this. And the triangle DBC, which is DBC, triangle DBC will be equal to the triangle ACB. DBC will equal to ACB, which looks absurd, right? So this is what he says, and therefore AB is not unequal to AC. So, and it is therefore equal to, let's look at the language. Therefore, AB is not unequal to AC. It is therefore equal to it. So basically it says AB is now equal to AC, and the assumption which we had made that, hey, AB is not equal to AC, AB is longer than AC, we cut off AC from AB, and then we get these two triangles which we prove them to be same, and which is absurd, and thus the assumption that AB is not equal to AC is not true. So this is proof by contradiction. And in today's mathematics, this is a very important method of proof. So I would have this book by Richard Hammock. It's called Book of Proof. And actually, if you see how to prove conditional statements, he gives 3 kinds of proofs, proof methods: direct proof, contrapositive proof, and proof by contradiction. So I'm not sure whether he would have any geometric proofs there, but let me just glance through it. So this example is an algebraic one. So if AB is in the set of integers, a square minus 4b is not equal to 2. Suppose this proposition is false. So you see that the number root, this is a very famous proof. The number root 2 is irrational. Suppose for the sake of contradiction that it is not true that root 2 is irrational. So you see, we take a contradictory stance and then we go and make the proof. I'm not sure he has any geometrical proofs. Okay, no problem. But I think this is perhaps the first proof in Elements by Euclid, which actually is a proof via contradiction. I don't think so. 5, 4, 3, 2, 1. None of them are contradictions. Proposition 6 is the first proof by contradiction. Fairly simple.